Have you ever wondered how things are built within our bodies? Why our bodies can regrow and repair themselves, and how we can pass on genes from one generation to the next? Yet none of our man-made objects have these traits. They're simply thrown away when they break, and they definitely can't reproduce. The answer lies in something called self-assembly. Self-assembly is a system where unordered parts come together in an organized structure, completely on their own. This means that a pile of parts on your desk should, in theory, be able to move around on their own, find one another, and build something useful. This seems impossible, like Transformers or the Sandman, but it's exactly how our bodies are built, how our immune system works, and why we can reproduce. Self-assembly is the factory and copy machines within our bodies that make proteins fold and DNA replicate. It's a process that not only happens in the biological and chemical world, but is a phenomenon that can be seen from magnets to snowflakes, robotics, social networks, the formations of cities and galaxies, to name just a few. In biology and chemistry, self-assembly is everywhere, from atomic interactions, cellular replication, to DNA, RNA, and protein folding. Proteins are like bicycle chains with sequences of amino acid links. They self-assemble into 3D structures because of the interaction between the amino acids along the chain, as well as the relationship between the chain and the environment. These forces make the flexible chain fold into a 3D shape that governs the function of the protein. Viruses, on the other hand, are like soccer balls. They're made up of a series of subunits with specific shapes. Those shapes have attraction to one another, so they fit together in precise ways. Imagine you want to build a perfect sphere. It turns out that making a precise sphere through traditional means is actually quite difficult. Alternatively, you could try to self-assemble the sphere. One way would be to inflate the sphere like a bubble or a balloon. Another option would be to create many identical pieces that would come together to make a perfect sphere. You could try to put the pieces together one by one, but it might take a long time and you'd still have human errors. Instead, you could design a connection between the components like magnets and dump them into a container. When you shook the container, all the parts would find one another and build the sphere for you. Self-assembly is being used as a new design, science, and engineering tool for making the next generation of technologies easier to build, more adaptive, and less reliant on fossil fuels. Scientists are now making molecular microchips for computers where small molecular elements are given the right conditions to form themselves into organized pathways. Similarly, we can now use self-assembly as a way to make 3D structures with DNA, like capsules that could deliver drugs inside the body, releasing them only if certain conditions are met. Soon, self-assembly will be used for larger applications, where materials can repair themselves, water pipes can reconfigure on demand, buildings can adapt on their own to environment or dynamic loading, and space structures can self-assemble without humans. Imagine if our factories were more like organisms or brains, and our construction sites were like gardens that grow and adapt independently. The possibilities are endless, and it's now up to us to design a better world through self-assembly.